In this section, we're going to talk about some measure of center. And actually, a lot of these topics you probably heard before, but we're just going to go more into depth. And one of the topics we want to talk about is something called the mean, which is just taking the sum of all of your data values and divided by the number of observation in your data set. And there's actually two types of mean. But before we talk about this, I want you guys to remember the difference between a population and a sample. A sample is just a subset of the population. So, for example, if we were talking about everybody in the United States, let's say you want to get everybody's heights, it could be very time consuming and sometimes impossible to get everybody's height in the United States. We're considering everybody in the United States as the population. So what people do is they take a sample, which is a subset of the population, and we do some analysis here. So the population mean is denoted as this Greek letter. It's called mu. It's just a very fancy U with a long tail in the beginning. And the way to compute the population mean is that all we have to do is take the sum of all your data value in your data set and divide it by the total number of observation in your data set. So here's a little note that n is just the number of data values or observation, and this summation here, so this just represents the sum of all the number. So this fancy E is another Greek letter, and it's called a summation. So what it does, it just symbolizes take the sum of all the number in your data set. And then the sample mean is denoted by x bar, and it's computed by taking the sum of everything in your data set of your sample and divided by the number of observation in your sample. And a very common misconception is that your mean doesn't always have to be in your data set. It is possible to compute a mean and it's outside of your data set. So let's look at this example. So let's say you took 5 exams and these are the scores that you got. And you want to take the mean. And since there's no indication about a sample, we're going to consider this as a population. So that's why we have to use mu, the Greek letter. So we have to take the sum of all of our data and then divide it by the total observation, which is 5, because we have 5 exams. And this gives us 81.2. And notice that 81.2 is not in our data set, which is fine because we're calculating the population mean. So let's consider this example. Notice that the word sample is in here, so that gives you an idea that we're dealing with a sample mean. So that's why we have to use x bar. And this is the sum of all our data values divided by the total number of observation in your data set, which is 12 because there's 12 employees. And this gives us 24.7. Another thing we could do is find the median. And the median is just the number that's right in the middle of your data set. So how do we find your median? Well, you have to arrange your data set from smallest to largest. Then you want to determine the number of your data value, which is n. Another word is just finding the number of observation in your data set. If your n is odd, then the median is in the middle number. But if n is even, then the median is the mean of the middle two numbers, or the average of the middle two numbers. So let's find the median of your exam scores. Notice that they're not in order, so that's the first thing you have to do, is put them from least to greatest. Then what I like to do is kind of cross out each number until you reach the middle. In this case, it's 83. So 83 is your median. So let's look at the example from the small company. Again, notice that it's not in order, so then you have to put them in order from least to greatest. Once you do that, what I like to do is cross each number until you get to the middle. Notice that these two numbers are in the middle. So what you have to do is take the average of these two numbers, which give you 24.5. Okay, so in this example, we have 5 families and we got their annual income. And the goal of this is to compute the mean and the median. So let's start with the median because that will be quick. So what you have to do is put the values in order from least to greatest, and then find the middle number. In this case, it's 34,000. So your median is 34,000. So then computing the mean, we have to take the sum of all these values and divide it by 5, because there's 5 families. So if you do that, that should give you 38,000. So then your mean is 38,000. Let's consider one of the families, let's say the Smiths, whose income was 25,000, and they won the lottery. So that means their income increased by $1 million. And the goal is to compute the mean and median of the neighborhood. And we're actually going to see something very interesting. So let's compute the median first. So what we have to do is put the values in order from least to greatest and find the middle number. So in this case, it's 44,000. Next, we want to calculate the mean. And we want to take the sum of all of our values and divide by the total number of observation, which is 5. And if we do this, we get 238,000. Now notice that the mean from this example and the mean from the previous examples are two drastically different values. And this is because the mean is very influenced by extreme values. And notice that the median is relatively stayed the same. So we're going to talk about why this is. So a resistant measure is a statistic that is not affected by extreme values. From the previous example, we saw that when we increase one of our data values by 1 million, the mean drastically changed. So because of this effect, the mean is not a resistant measure because the mean was affected by extreme values. However, the median, we kind of saw with the median, it relatively stayed the same. It kind of stayed in the same position. So that means that the median is a resistant measure. So this kind of begs the question is, which one's better, the mean or the median? Well, both of them have some advantages and disadvantages. It kind of depends on what data set that you're dealing with. So here, I made a little chart that we could discuss about some advantages and disadvantage for both the mean and the median. So some advantages for the mean is that it takes every value into account. And some advantages for the median is that it's not much influenced by extreme values, kind of like what we saw from the example. Some disadvantages for the mean is that it's highly influenced by extreme values. And this could be bad, depending on what you're working with. And some disadvantage for the median is that it only depends on the middle value. Another thing you want to notice is that we can actually compute the mean and median for any list of numbers. But sometimes we don't want to because we have to think about their meaningfulness. For example, let's say I have the heights of basketball players. So I have these are a list of numbers. So let's say these are the height of basketball players in inches. And I also got their jersey numbers. So these are two lists of numbers. I could take the mean and median for both of these, but I don't really want to take the mean and median of their jersey numbers because that's not really meaningful. It doesn't tell me anything. So you have to be careful with that. So let's consider the mode. So mode is just the most frequent value that occur in your data set. And if you want to think about it visually, the mode is the highest point on your histogram. So let's look at this example. 10 students were asked how many siblings they had, and we had this data set. You kind of see that the number 1 occurs the most, so your mode is 1. But let's consider a different data set. So what if your data set kind of looked like this? What would our mode be in this case? Well, our mode would just be 1, 2, and 3. So it's perfectly okay to have more than one mode. Okay, so let's consider this data set. Just a bunch of 2s. What would our mode be? Well, actually, there's no mode. And the reason why is because since all the numbers are the same, there's no one number that's the most frequent. So let's look at this example. You have this list of cars and you want to figure out the mode. And you kind of notice that the mode here is Toyota. But another thing that's pretty interesting is that, is it possible to compute the mean of this data set? No, right? Because this is just a list of names. Is it possible to compute the median? Again, no, this is just a list of names. But it is possible to compute the mode. So that's pretty interesting about the mode is that it works for both quantitative and qualitative data. We talked about mean, median, and mode, but what does that mean graphically? Like, what does that mean on a histogram? So here, the measure of center and the distribution of our shape, they kind of have a correlation. So let's look at this histogram. So we know this is skewed to the left because if you imagine a ball on the top and if you push it, it goes to the left. And fun fact is that if your histogram is skewed to the left, then your mean is actually towards the left tail. And since you know your mode is the highest peak, this will be your mode. So that means the middle will be your median. Okay, now in this histogram, we know it's skewed to the right. And again, imagine there's a ball on the top. If you push it, it goes towards the right. And similarly, if your histogram is skewed to the right, then your mean is toward the right end of the tail. And you know that your mode is the very top of the peak, so this will be your mode. So that means this is your median. Notice that when you're skewed to the right, your mean is higher than your median, but when you're skewed to the left, your median is higher than your mean. And if your histogram is symmetric, then your mean and median is the same. And in this example, your mode will be also the same, but that doesn't happen all the time. Because let's consider this example. Here we have 2 modes. So both of these will be our mode because they're our highest peak, and our mean and the median is the same because this is symmetric. So I wrote down a little summary here about what happens when you skew to the right. Your mean is greater than your median. When you're symmetric, your mean is about the same as your median. And when you're skewed to the left, your mean is less than your median. So let's go over some examples. So let's say your data has a mean of 6 and a median of 4. Well, we know that your mean, which is 6, is greater than your median, which is equal to 4. So that kind of means that your histogram is skewed to the right. Kind of the same here. Let's say your mean was 5, and 5 is less than your median, which is 7. So from our little table, we know that this is skewed to the left.